Okay, Assalamualaikum. Saya akan mulakan hari ini punya lecture untuk topik 10. So, kita akan sambung lecture yang pertama, habiskan yang hujung tu, dan kita akan habiskan lecture kedua juga dalam video yang sama. Okay, so last time we stop at the finding the value of R, right? And then now we should start with the coefficient of determination. Okay, this is 10.2 D. Okay, but as we learn how to find the value of R, so we can continue to find the value of R squared also. Okay, so if we follow the learning outcomes, it should be 10.1A. We solved it last time, and then this is 10.2D. Solve and interpret the coefficient of determination. Okay, so to find the coefficient of determination, and then we have to know how to interpret it. Okay, so what is coefficient of determination? Okay, so coefficient of determination, or we represented it as R square. So denoted by R square is equal to n multiplied by summation of xy minus summation of x summation of y divided by square root of in the bracket of n summation of x square minus summation of x all square close bracket multiplied by open bracket again and summation of y squared minus summation of y all square close bracket. And then we have to square this value. Okay, so the same as the representation of the coefficient of determination, which is the R squared, means that we just have to find the coefficient of correlation and then we square it. Okay, so this coefficient of determination denoted by R squared shows the proportion of the total variation in the dependent variable y that is explained or accounted for by variation of in the independent variable x. So if we have a square value, any value will be always positive, right? Because yes, the value of negative, if we have to square it, then we will have a positive value. Okay, remember that we have only value for the R, which is the coefficient of correlation, from -1 up to 1 only. So if we square all the values on that number line, we will have the value in between 0 and 1 only, from 0 to 1 only, right? If we have R equal to -0.2, then if we want to find the coefficient of determination, we square the -0.2 and then we will get the square value will be positive 0.04. Okay, so that's why the value of the coefficient of determination, it will be in between 0 and 1 only. From 0 to 1 inclusive. Okay, coefficient of determination is a measure of variation of dependent variable y that is explained by the independent variable x and the regression line y cap equal to a plus bx. Okay, so why y cap? This y cap is actually the representation of the linear correlation, linear regression. Okay, we will use this value to find the equation. If R squared equal to 0.9, means that 90% of variation in Y is caused by independent variable X. Okay, so this is how we interpret the coefficient of determination. So after we find out what is the value for R squared, this 0.9 is the probability. Okay, probability that the Y depends on X. Okay, so how to interpret it? We have to use the percentage value, which is if 0.9, then it will be 90% of the variation in Y is caused, okay, by the independent variable X. Okay, and the regression line lah. Okay, one, so the remaining, which is from 90%, the remaining will be 10% of the variation in Y is caused by other factors. Okay, so means that the R squared value is the probability or the percentage of the that will be causing the variation in Y. Okay, so 90% nilai di dalam Y tu disebabkan X. Tapi baki dia 10% mungkin sebab lain. Kita tahu sebab apa, tapi kita boleh cakap macam tu je lah. So this is you have to take note lah. This is the part where you interpret the coefficient of determination. Okay, so let's see the example lah. find the coefficient of determination R squared for the following data. So kat sini soalan dia directly to find R squared. So you have to use the formula directly. So you do not find out the coefficient of correlation and then square it. No, we just directly use the exact value from the calculator and square it. Okay, so let's say to find the coefficient of determination, the same step as the coefficient of correlation, we need to find the summation, all the summation lah, which is summation of x squared, summation of x, summation of y squared, summation of y, and summation of xy, and also the value of data n. Okay, so for n, we can calculate it manually, just count it. So we have 1, 2, 3, 4, 5, 6, 7, 7 data. So for n, we directly know it's 7 data. And then for all that value, what we need to do is to find the summation by using calculator. Okay, so let's us find it together. Okay, so this is my calculator. So we have data, set the mode, stats, and choose the number 2, the linear. So now we have x and y. So we also can first turn off the frequency for stat. So off number 2. So we start again. So stats and linear. Okay, now so, put the value for x and y. So we have 1, 2, 5, 7, 8, 9, 10. And then for y, we have 7, 9, 13, 15, 14, 17, 20. Okay, now we have all the data. We need to find what is our summation of x squared. Press the AZ and shift 1. So here we have the sum and the regression, number 3 and number 5. So we want to find the sum first. So summation of x squared, number 1, is equal to 3 to 4. Okay, so it's 3 to 4. You can put it in your slide lah, in your calculation, 3 to 4. And then shift 1 again, summation of x, number 3 and number 2. So we have 42. Is it the same as yours? And then the next one is shift 1 again, sum. We want the summation of y squared 3. So we have 1409. And shift 1, 3 again, we want summation of y, which is 4, equal to 95. And then lastly, shift 1, 3, summation of xy, which is 5, equal to 660. And we also can find the n. Shift 1 again and 3, the number of n. Oh, we don't have n here. Shift 1, data. You can just count on the side lah how many data we have. So the data include in this is only 7 data. Okay, so settle for that summation. And then we also can check we can directly check what is the R, but we don't want to use this R because this R has been round off. We want the exact value. Okay, so shift 1, if you use the 5, we don't have R squared, we only have R. But we want the R lah, not R squared. Because if we take the value of R here and then we square it, then it won't get the exact value. Because the question directly asks you to find the coefficient of determination. Okay, so now let's see the summation. Is it correct with the one I find by using calculator? Okay, we have the same value. Now, to find the coefficient of determination, we use the formula R squared lah. So R squared is equal to, we put the value n is equal to 7, summation of xy is equal to 660, summation of x is 42, summation of y is 95, and divide by n multiplied by summation of x squared, which is 3 to 4 minus summation of x 42 square. And then multiply in a bracket 7 multiplied by 1409, which is the summation of y squared minus summation of y and then square. Summation of y is 95 and then square. And then we have to put square on the outside lah. Okay, so if you use calculator directly. Okay, let me open the screen to choose the calculator. Show taskbar, my calculator. Now I want to put the value lah. So I put bracket and then fraction. Okay. Now we cannot use that. So bracket again, 7 of 660 minus 42 of 95. 95. So close bracket for the top. And then divide by, in a bracket, square root of 7 multiplied by 3 to 4, close bracket, minus 42 square. Close bracket, open bracket again. 7 of 1409, close bracket, minus 95. Close bracket, 95 square. Close bracket, and then we have to square the value because I put the bracket for everything and then square it. So we get the answer equal to, wait, there must be something wrong somewhere. Okay, divide by. So if you use divide, square root, I think we need to put square root here. Square root of, open bracket, multiply by, close bracket. No. Okay, so let us do step by step. Okay, so we have 7 multiplied by 3 to 4, close bracket, minus 42 square, close bracket, and then multiply by, in a bracket, 7 of 1409, 1409 minus 95 square. Okay, so we have a bracket in the denominator, so calculate it. So we have the answer, so square the answer. So we have the bottom one, and then now the top one, we need to, in a bracket, 7 of 660 minus 42 of 95. Okay, now close the bracket, divide by the answer. We have square root of the value earlier. So we have this for the answer of the in the bracket. Now to find the value of r squared, we need to square the value. Why? You cannot simplify it first. You cannot just find r and then square the r because you run off the value to the 4 decimal, right? Now we want to use this exact value to find the determination. So we square the answer. Directly use the answer square, equal to 0.9397. Okay, so if we round off it, the answer might be different. So follow the question. The question asks you to directly find the r square. Okay, so now we have the r square, which is equal to 0.9397. Okay, so for example 4, you have to round off for the decimal place, 4 decimal places at the end. Okay, not the r, but at the end after you square the exact value. Okay, so how to interpret this question? So the question didn't ask you to find it, to interpret, so we can leave it like that. So let's continue with example 5. Okay, so example 5. June Slimming Center collects data to demonstrate how aerobic exercise can affect weight loss. Okay, the total aerobic exercise in minutes per week and the weight loss for 9 members are recorded. The data is given below. Okay, find the coefficient of correlation R and interpret. Hence, find the coefficient of determination R squared and interpret. So, what the question asks you to find? First, to find R and interpret. letter, find R squared, interpret. Okay, there is hence. Okay, for this one, they ask you to find R first. And then after that, baru kita cari R squared. Okay, for this one means that you use the runoff value lah. Okay, because there is hence question. So we need to use the previous answer to answer R squared lah. Previous answer is R. So the round of R and then we square it to find the coefficient of determination. Okay, let's see how do we do this one. Okay, so we have all this data. Use your calculator to calculate the summation of x squared, summation of x, and summation of y squared, summation of y, and summation of xy. Okay, so I want show the calculator part. So directly we use the value here. Okay, now to find the coefficient of correlation. Okay, so put the value and then we can check by using the calculator lah. For this one, we have the value in the calculator after. So calculate manually and then check whether your answer is correct or not. So after we use the calculator, we should get the answer R equal to 0.9940. So now we have the R run off to 4 decimal places, right? Okay. If you want to check, let me check by using my calculator. Not using this calculator. Okay. I want to find the number 6, number 2, and then put the value we have. Go back. So 70, 117, 195, 176, 153, 198, 240, 242, 180. So we have 9 data. So this one 0.5, 1.3, 2.9, 2.4, 2.0, 3.1, 3.9, 4.2, 2.6. So calculate shift, option. So we have two variables. No, we want to find the regression calculation. Okay, and then option, regression calculation, summation. Okay, so my summation back, I want the data. Okay, data. Okay, two variable. Mana? Sorry, option. Editor now. Issue two variable. Alah. Oh, sorry. Let me check. No lah. We just use this value and then put in the calculator. We get this value 0.9940, right? And then they ask you to interpret. So you interpret there is strong positive linear relationship. Okay, now use the keyword linear relationship. Okay, so this value 0.9940 is near to 1. And then but we use the strong positive lah. It's positive value, so strong positive linear relationship between duration of aerobic exercise and weight loss. Okay, now to find the coefficient of determination. So R is equal to 0.9940. So R squared, you just have to square 0.9940, not the answer. Directly we square what we have for R, we get 0.988. And then now we have to interpret, we use the percentage lah. So for the percentage, it will be 98.8%. So how do we interpret? About 98.8% of the weight loss is caused by the duration of aerobic exercise in minutes, while the remaining will be 1.2% is caused by other factors. Okay, so this is how we interpret the R square. Okay, so please take note, in the exam, you should write down your answer like this. Okay, so that's all for lecture 1. Now we continue with regression, lecture 2. Okay, so lecture 2. Okay, okay, so we continue with lecture 2. So Here we are going to focus on 10.2 directly, which is the simple linear regression. So the learning outcome at the end of this lesson, students should be able to first, so now we are going to focus on the learning outcome A, B, and C because we focused on D last time. Okay, so students should be able to, first of all, to find regression line using the least square method. Okay, we only focus on one method, which is the least squares method, and then interpret. Okay, after we find out the regression line, now we interpret. And then lastly, produce y cap equal to a plus bx using the regression line. Okay, we want to find the equation, representing the regression line. Okay, what is least square method? So the relationship between two variables can be obtained by finding the best fitted line. Now we want to find, we have the raw data, right? The dotted line, the scattered diagram, right? So how to represent the scattered diagram? The best is to find the fitted line lah, which is known as regression line. We only discuss y on x lah. Satu y on x, only one independent variable. Okay, the linear regression line as y cap equal to a plus bx. This is linear regression line. So to solve for a and b, we use the least square method. So we have the formula for b and a. So we just apply the formula into b and a, then we will have the answer for the line lah. So we can find out what is y cap, which is a plus bx. So we just have to find value a and b. So apply the formula for b and a. Then we will have the equation. So x is called the independent variable and y is the dependent variable. So this y will depend on x. And a and b are called the regression coefficient. So if the question asks you to find regression coefficient, so you have to find a and b. B is the gradient of the regression line and A is the y-intercept. The same thing as we learned in straight line. Y equal to mx plus c. So here the m is B. The A is the C, which is the y-intercept. Okay, so let's see directly the example. So the table below gives the mark obtained by 10 students taking mathematics and English tests. Find the equation of the regression line y on x by using the least square method. So what we need to do to find the A and B. So to find A and B, we need to know all the summation we need to use in the formula, which is for B, we need to find what is summation of xy, summation of x, summation of y, and summation of x square. We don't have to find summation of y square. Okay, we don't have it in this. And then the next one is to find A, which is the summation of y over n. So this is y bar. So we use the formula of average. Y bar is average. So the same thing as mean. So we have to use summation of y divided by the total frequency, which is n. And then also this is x bar, the average for x. Summation of x divided by n. Okay, now what we need to find is summation of xy, summation of x, summation y, summation of x square, and n. So what is summation of x square? The same method we use to find the coefficient of correlation, which is we use the calculator method lah. So I don't want to show that part because we learned together. Okay, now just apply what we learned in lecture 1. So we will have all this summation. So now just put in the value of B. Okay, so we get the answer after you use calculator, you get the answer B is equal to 0.92. Okay, so let's see if you want to use the calculator. So let's see how we use the calculator. Okay, if we substitute the value shift. Okay, 3, 2. So put the value. What is our value? We have 20, 23, 8, 29, 14, 11, 11, 20, 17, 17. So 10 students, right? So then 30, 35, 21, 33, 33, 26, 22, 31, 33, 36. So we will have the summation No. AC first and then shift 1. The summation we have. Now to find the regression, we can use number 5 here to check whether our value for B is correct or wrong. So this number 2 is the value of B. So we choose 2 equal to 0.59166667. Okay, so after we round off it, we will have 0.592. Okay, the answer is correct. Now to check the answer for A, shift 1A. So 5. So choose 1 and then equate. So the next value, we want to find A, right? Apply the formula. The answer will be 19.9417. Okay, so let's check together. So after we substitute the value, we will get the answer equal to 19.936. Is it the same? Is it the same? You screen show those first one. 19.9. Oh, difference. Okay, so it will be different. So now what we need to do is to, yes, why is it different? Why is it different? What do you say about this? Okay, because this A will, in the calculator, they will use the exact value for B. But for us, we use the round off value of B. So we can check for B, but we cannot check for A. Okay, so just check for B only. This one we can check using calculator, but not A. Not A. Don't check, don't check because the answer will be different. Okay, this one correct. Yes, we can check using calculator, but later because we substitute the round off value, the answer for A will be different. Okay, so please be careful here. Okay, now we have the value of B and A already. So what is Y cap? Y cap can be written as A plus BX, which is 19.936 plus 0.592x. So this is the answer for the regression line. Okay, so done. Now, example 2. Find the least square regression line for the data on incomes and food expenditure on the 7 households given the following table. Use income as an independent variable and food expenditure as the dependent variable. Interpret the results. So, the independent variable is income. So, income will be X. And then the food expenditure will be the dependent. So, it will depend on X. So, it will be Y variable. And then interpret the results. So, we want to find the least square regression line. Means that we have to find A and B, and then Y cap is what? Okay, and then interpret the results. So what we need to do, the same thing we used earlier, we need to find the summation, all the summation, which is summation of x squared. Use a calculator, we get 7222. And then for summation of x, we get 212. For summation of y, 7, and n is 7. Summation of y is 64. Summation of xy is equal to 2150. Now substitute all the value into the formula B. We can directly check is equal to 0.264. Now to find the value of A, substitute the value of summation of y over n minus the B we have in this part, and then multiply by summation of x over n. So we have the answer is equal to 1.147. Okay, now we have the A and B. The y cap is equal to the A 1.147 plus the B 0.264 and multiply by x. Okay, so this is the y cap, the least square method, the least square regression line. Okay, now to interpret, how to interpret this? Okay, interpretation. So let's see what is the value of 1.147 and 0.264 indicates. So 0.264 is the gradient, right? So for the gradient, for the A is the y. This is y-intercept, right? So y-intercept, we will have it when the x is equal to 0. Okay, so when x equal to 0, okay, 0 income, so we have y is equal to 1.147. So what we can conclude from here, thus we can state that household with no income, because 0 income, we can say it's no income lah. It's expected to spend RM 1.15 ringgit on food. Okay, so this is in the unit of RM. So please use RM lah. It's this is 1.147. So but because RM we have only 2 decimal places, so it will be RM 1.15 on food. Cakap mana? X kosong. X kosong tu maksudnya tak ada income pun, diorang kena spend juga duit untuk makanan. Betul tak? Tapi tak logik lah sekarang ni RM1.15. Tapi dia expected to spend. So use this part to explain the relation between the Y and X. Okay, kalau X dia kosong, Y dia masih kena guna sebanyak 1.15. Okay, we still have the Y equal to 1.15. So what is X? X is talking about income. So no income, zero income means that we still have to spend. Sebab nilai Y is talking about the expenditure. So expected to spend RM 1.15 ringgit on food. For B, the regression line is reliable only for the values of X between. Okay, so this part, the second one here, is talking about the value of X lah. Okay, nilai X ni kita tengok daripada data yang diberikan. Nilai X tu daripada mana ke mana saja. So the smallest X is equal to what? The largest X is equal to what? So let's see the original data. So the smallest X, so we have income. The smallest X kat sini ada berapa? So we have the smallest one is 15. The largest one is 49. So we can say that it's only valid for 15 to 49. So this is interpretation of A. Why? Because A is talking about when the X is what is what. Okay. So first, when zero income, when X equal to 0. And the second one to talk about the range of the X. 15 to 49 only. Out of, kalau kita letak nilai contohnya dia suruh cari. Okay, later kita akan tengok example. If we have the X, dia kata find the expected expenditure. If the income is, let's say 5, can we find it? Okay, so it's not in the range, so we have to come out with some reasoning lah kat situ. Okay, later we will see it in example lah. Next example. So how to interpret B? Interpretation of B. So because the B is talking about the gradient, okay? So the value of B in the regression line give the change in Y due to every unit change in X. Bila X kosong, tak ada kan? Tapi bila X 1, dia akan naik sebanyak 1 darab 0.264. Kalau 2 kali ganda 0.264. So every unit change. Okay, so what we can do in interpretation of B is we can state that on average, RM 1 ringgit increase in income. Why? 1 ringgit. X is RM. This is talking about X lah. X, kita bertambah 1X, increase in income lah. X is income of a household will increase the food expenditure by this gradient lah, which is 0.26 ringgit. 2 decimal places because RM. Okay, so it's talking about RM unit kan. Everything should be in RM lah. Everything should be in the same unit. Why? It's a linear equation. So everything in the same unit. So that is how we interpret for B. Okay, so expenditure by 0.26 ringgit. 1 increase in X will increase by 0.26 in Y. Okay, so now continue with example 3. The following table shows the result of an experiment where 8 similar plots of land were given different amount of water in centimeters cubed, and the resulting yield of corn in tons per acre was recorded for each plot. Okay, so we have amount of water, how many water in centimeter cube, and then yield of corn, Y. So Y is talking about the unit of ton in acre, ton per acre. Sorry. Betul lah, ton per acre. So find the equation of regression line on Y on X. Interpret the regression coefficient. Okay, now we have to find the equation Y cap equal to A plus BX, and then we need to interpret the A and B lah. So what will you expect the yield to be for a plot where this one that I talked about earlier. So they ask you to find the expected y when we have the x here. So comment on the reliability of the result obtained in C. So is it the expected value can be reliable? Because why? So it's talking about the range of x lah. So now to find the B and A, to find the equation, we need to use the summation, all the summation to find B and A lah. So we get this value for summation of x square, summation of x, and summation of y, and summation of xy. And then put everything in the formula for B, which is we get the answer equal to 0.031. And then for A, we get the answer equal to 3.611. So for A, we need to use the answer we have in B. Okay, after you round off it. Okay, so let's check, is it correct? Is it after you round off it? I go, wait screen, show taskbar. Okay, so let's check together. It's in the bracket of 49.97 divided by 8 close bracket minus 0.031 multiplied by 680 divided by 8, so 3.61125. Okay, you may check by using calculator for A, but the answer will be different. That's why we need to use the round off value here. Okay, so now we have the value for A. So now what is y? Y cap is equal to A, which is 3.611 plus bx, so 0.031x. Okay, next we need to interpret the regression coefficient, which is A and B. So for B, it's 0.031. We can say that for every increase in 1 centimeter cube of water added, the yield of corn increased by 0.031. What is the unit for Y? So this is in X. Every X, it will increase by 0.03, which is the coefficient, ton per acre. Okay, here is talking about centimeter cube and ton. So the X is in centimeter cube, the unit, and the Y is in unit of ton per acre. So it's different from the previous example because the previous example is talking about income, which is RM, and then the expenditure is also in RM. So please be careful with the units lah. So here you can use up to 3 decimal because we don't have the limit for the ton per acre. Not the same as RM. RM, we only have 2 decimal places lah. If you put 3 decimal places, the answer will be wrong. So please be careful. Okay, next, interpretation of A. A equal to 3.611. So when X is equal to 0, this is y-intercept. Okay, so the intercept is 3.611 and can be interpreted that without any water added. Why without any water? X equal to 0. So what is X? Amount of water. So no water. Without any water added, 3.611 tons of corn per acre will be produced. Okay, A is in unit Y lah, because when X equal to 0, you get the answer for Y. Okay, which is Y is equal to 3.611. So what is the unit for Y? Y is ton per acre. Okay, so now this is the interpretation for question B. For question C, what would you expect the yield to be for a plot where 70 cm cube of water was added? So we just put in the question, in the equation that we have found in A, to find the value of Y when X equal to 70. So using the regression line equation we have in A, so we have X equal to 70, so Y is equal to 5.781 acre. So we can say if 70 cm cube of water used, then 5.781 tons of corn per acre will be produced. Okay, so this is our value and the interpretation. Okay, now just find out by substitute the value of X. For number 2 also 190 cm cube of water. So put the 190 into the regression line, we get the answer 9.501 tons per acre. Okay, so just find out what is the result. But now for question D, comment on the reliability of the result obtained in C. So we have two value lah, which is for x equal to 70 and for x equal to 190. So are these two value reliable? Okay, for x equal to 70 cm cube, okay, we can check earlier our data given in the question. So what is the range for x? So we can say the smallest value here is 35. The biggest one is 130. Okay, so this is the range we have for the amount of water. Okay, but for question C1, it give you 70. 70. So earlier 35 to 130. So 70 is within the given data. So this is our range for x, right? So we can say that x 70, so it within the given data. Okay, dia ada di dalam data, bukan adalah, kiranya berada di antara nilai-nilai yang diberikan. Okay, it is called interpolating. Maksudnya di dalam range kita, maksudnya kita macam plotkan dia, nilai dia tu memang di dalam range dia. So tak ada masalah. Would result a good estimation kat sini. Because interpolating, so maksudnya takkan lari jauh lah. So it's a good estimation lah for the amount of corn produced. So maksudnya memang boleh expect lah sebanyak ini, Y cap ni, amount of corn produced. But for X equal to 190. Okay, 190 ada tak dalam range ni? Luar kan? Sebab kita paling tinggi pun 130. 190 is more bigger than 130. So we can say it's outside the given data. 70 within the given data. The difference is this one is within, this one is outside the given data range, and it is called as extrapolating. So we have two types of data yang expected value ni. Kita boleh expect value. Satu, kalau dalam data, within the given data, kita panggil dia interpolating. But for 190, it's outside the given data, we call it as extrapolating. Therefore, this 9.501 tons of corn per acre is not a good estimation. Not a good estimation. So, kalau kita dapat yang interpolating, so it's a good. Interpolating, good. Kalau extrapolating, not good. Okay, so itu saja untuk lecture ni. So, what we learn in topic 10 is just that we need to find what is R, and then we use this R, and then we also find the regression line, which is find the A and B, and then we can interpret all of these, and then after interpret, we can estimate, and then we can interpret again, and lastly we need to find the R squared. Okay, so R squared, what do you have for R squared? And then we have to interpret. So lastly is R squared, but we learn it in lecture 1 because it's the same calculation with the R. Okay, so that's all for topic 10. I hope you guys understand everything and ace this topic. So it's really simple. You just have to follow what I give you in the lecture. Nothing will be out of the lecture lah biasanya kalau untuk topik ni. Okay, so that's all for lecture 2. Oh, sorry. This is what we said earlier. The regression line is valid only for the values of x between 35 to 130 lah. What I said earlier. Okay. So it's the end for lecture lecture 2 of topic 10. So the end for the topic 10. So later I will upload for the topic 11 lecture 1. Okay, so I think that's all for this part. So see you guys on topic topic 11. Okay, thank you.